Good morning. This is Unit 1, Day 4 notes, and we're going to go over, it says the 12 basic functions. These are some of the things that we're going to talk about these graphs. So let's look at the identity function first. It's f of x equals x, and this one should be pretty straightforward for you. F of x equals x is just a straight line. It looks like this. The slope is up 1 over 1, up 1 over 1, and it has a y-intercept at 0. So the domain are your x values, and it goes infinitely to the right and infinitely to the left. So my domain is going to be negative infinity, comma, infinity. We use parentheses when we're using infinities. The range are our y values, and the y values go down infinitely and all the way up infinitely. So this is going to be negative infinity to infinity also, parentheses. Now the end behavior is going to be something that you should have seen before. Usually we say as x goes to negative infinity, what does your y value go to? And as x goes to infinity, which positive infinity, what does your y value go to? And it's usually like up or down. So let's look at this one. As x goes to negative infinity, that's to the left. As we go to the left, we're going down to negative infinity. But as we're going to the right, or to positive infinity, it looks like our y values are going up. So that's also positive infinity. And I don't know what other means, so let's keep on going. So this one says f of x equals x squared, and this is a parabola. So this one, parent function, looks like this. If I plug in 0, we have 0, 1, we have 1, 2, we have 4. So something like this. And it is symmetric. It is an even function. And it goes up infinitely. Alrighty, so we're going to talk about the same thing. The domain of our x values. We're going to the left forever. It's going to go up into the left forever. And we're going to go up into the right forever. So the domain, or our x values, are going to go from negative infinity to infinity. The range are our y values. So this is never going to go below 0 for the y value. It's never going to go here to negative. So we're going to start at 0. And actually, I can include 0 because that is an ordered pair, 0, 0. And then it's going to go up infinitely for the y values. So I'm going to say this is infinity. The end behavior, again, it's pretty straightforward. We're always going to say as x goes to the left and as x goes to the right, what happens to our y values? So negative infinity means to the left. As we go to the left, we're going to go up. Up means infinity. As x goes to the right, positive infinity over here, we're going to also go up. So this is also y goes to infinity. And that's it. This function, f of x equals x cubed, is symmetric about the origin. So this looks kind of like this. 1 cubed is 1, 2 cubed is 8. So it's going to be pretty, goes up pretty steeply. So I'm just going to kind of go like this. And something like this. Negative 2 cubed is negative 8, so it touches down here. So it looks something like that. That's my parent function. The domain are x values. It looks like it goes down forever, but it keeps on going to the left. So it's going to be negative infinity. Pretend like that's an infinity, comma. And it's going to go up, but it's also going to go to the right forever. We can plug in 6, 100, and it'll still keep going. So it's going to go all the way to the right, which is infinity. My range, it goes down forever. There's an arrow at the end, and that is negative infinity and it goes up forever, so that's also infinity. My end behavior pretty much is talking about this. So we say as x goes to the left, what happens to our y value? I don't know, y goes to something. And as x goes to the, sorry, this is right, the left, let me do left first, and then right, our y value goes where? So negative infinity means to the left. Negative infinity is over here. As we go to the left, our y values are dropping. They're going down. So this is going to be negative infinity. And as we go to the right, over here, as we go to the right, it looks like our y values are going up. So this is going to be positive infinity. The square root of x looks something like this. I know that 0, the square root of 4 is 2, and the square root of 1 is 1. So something like this just goes up and very slowly. It does go up forever, but it goes up very slowly. We cannot plug in negative numbers into your square root sign. We can't plug in like -1 into there. So my domain is actually going to start right here at 0, 0. 0 works. Square root of 0, 0. So my domain starts at 0. We can include that. And our x values go all the way to the right. So we can get bigger. We just can't get smaller. Now my range also starts with 0. And we can't have negative range for square roots. So it's going to also start at 0. And it's going to go up. It looks like there might be an asymptote, but there's not here. It goes up forever. So it just goes up slowly. The end behavior, again, we're going to do the same thing. As x goes to the left, and as x goes to the right, my y value goes to what? As we go to the left, ooh, this one's tricky. We don't go all the way to the left. We don't go forever. We actually are going to go until 0. So we can't go to negative infinity. As we go to 0, my y value also goes to 0. And as we go to the right, infinity, our y value is also going to go up infinitely. It goes up forever. I keep on wanting to have you guys try one, but these are all different. So let's look at a log. A natural log is just a log base e. We will go over this year. Refresh yourselves with it. Try to find it on the calculator. It's going to look like this, natural log. And a log base e just looks like, I would just graph this. It goes through this point, and I think like something like this. So the thing with the logs is there is an asymptote here on the y-axis. It doesn't ever cross the y-axis. There's a vertical asymptote. So we have the domain of logs, or specifically this log, natural log, is going to be, it's going to get infinitely close to the y-axis where x equals 0, but it's never going to touch the y-axis. So I'm going to use a parenthesis, and then it's going to go all the way to the right forever. So this is the parenthesis to, or 0 to infinity. The range, it goes down forever. So this is negative infinity. And then it goes up forever. It's going to keep on going forever, forever. And this is positive infinity. The end behavior is pretty similar, but we can't go down. We can't go to the left forever. There's an asymptote right here. So we're going to say as x approaches this asymptote, which is when x is 0. And then we can go to the right forever. So as x goes to infinity. What happens to our y values? Well, we can look at the domain and range. As x goes to 0, we're going to go down forever, get infinitely close to it. So down forever means negative infinity. And then as x approaches positive infinity, our y value goes up forever. So this is y goes to infinity. Exponentials are pretty much the opposite. They're reciprocals of one another, inverses of one another. So exponential functions, e to the x, is the inverse of a natural log. The domain and range of inverses pretty much just switch. Instead of having a vertical asymptote, there's going to be a horizontal asymptote. It's never going to pass the x-axis, and these points switch. So instead of being at 1, 0, now it's going to be 0, 1. And then it's going to go up like this, pretty much. And it's never going to touch that x-axis. So the domain looks like it's going to go to the left forever, which is negative infinity. And it's going to go to the right forever. It's going to go up very quickly, but it's still going to the right forever. So that's positive infinity. The range are our y values. It's never going to go down below this x-axis, and that's where the range is 0. So this is 0, and it's going to go up forever. So our y values go all the way up to infinity. The end behavior is just going to switch. So we can say as x, this time we can say as x goes to negative infinity, that's fine. Goes to negative infinity, and as x goes to positive infinity, what happens to our y values? As x goes to negative infinity or to the left, our y values go really, really close to the x-axis, which is when y equals 0. It's never going to touch it. It's going to go very, very close to it. As x goes to the right, our y values go up forever. So that is y goes to infinity. Alrighty, guys. I want you guys to try to graph the rest and try to answer these questions. If you have any questions, please let me know. All right, have a wonderful day.